8.5 billion years ago, a galaxy was being ripped apart, not by a black hole, not by a collision, by wind. Invisible, superheated wind blasting through a galaxy cluster so violently that it tore streams of gas right out of the galaxy's body, leaving glowing trails of newborn stars in its wake. And the James Webb Space Telescope just caught it on camera. This is the most distant jellyfish galaxy ever observed, and it's forcing astronomers to rethink what the early universe was actually like. So what exactly is a jellyfish galaxy? Picture a galaxy moving at tremendous speed through a cluster packed with other galaxies. Between those galaxies, there's searingly hot gas called the intracluster medium, reaching millions of degrees. As the galaxy barrels through, that gas acts like a fierce headwind, pushing the galaxy's own gas backward into long, trailing streams. The result looks a lot like a jellyfish drifting through the ocean, with luminous tentacles flowing behind it. Astronomers call this process ram pressure stripping. Think of it like sticking your hand out the window of a fast-moving car, except instead of air resistance, it's million-degree plasma peeling gas off an entire galaxy. The galaxy in question is cataloged as Cosmos 2020-6-35829. A team led by Dr. Ian Roberts at the University of Waterloo discovered it while combing through Webb data from the Cosmos field, a well-known patch of sky that sits away from the Milky Way's dense plane, giving telescopes a clearer view into deep space. Roberts and his colleagues were specifically hunting for undiscovered jellyfish galaxies in this data, and they found a remarkable one early in their search. Webb's infrared imaging revealed a galaxy with a fairly normal-looking stellar disk, but trailing off to one side were bright blue knots of light, clusters of extremely young stars. These stellar clumps are each about 100 million times the mass of our Sun and less than 100 million years old. That means they weren't born inside the galaxy itself. They formed outside it, in those stripped tails of gas, like sparks flying off the back of a speeding vehicle. The tail extends roughly 65,000 light-years beyond the main disk, a massive plume of creation trailing a galaxy under siege. Here's where it gets really interesting. Cosmos 2020-6-35829 sits at a redshift of 1.156. In astronomer speak, that means the light we're seeing left this galaxy about 8.5 billion years ago, when the universe was only around 5.3 billion years old, still in its cosmic adolescence. Before this discovery, scientists widely believed that galaxy clusters at that early epoch were still forming and hadn't yet developed the dense environments needed to produce ram pressure stripping on this scale. This galaxy says otherwise. Dr. Roberts highlighted 3 key takeaways. First, cluster environments were already harsh enough to violently strip galaxies of their gas far earlier than expected. Second, galaxy clusters may have been reshaping the properties of their member galaxies much sooner than our models predicted. And third, this process likely contributed to building the large population of so-called dead galaxies, ones that have completely stopped forming stars, that we observe in galaxy clusters today. That last point matters a lot. One of the biggest open questions in astronomy is why so many galaxies and clusters appear lifeless, drained of the cold gas they need to keep making stars. Cosmos 2020-6-35829 provides a rare snapshot of that process actually happening during a critical period of cosmic history, near what astronomers call cosmic noon, when star formation across the universe was at its peak. The findings were published in the Astrophysical Journal in February 2026, and the team plans to continue studying this galaxy with Webb to uncover even more about the forces that shape galaxies in extreme environments. If this discovery surprised you, or you learned something new, subscribe and turn on notifications so you catch every new deep space story we cover. Drop a comment and tell me, what do you think happens to all those orphan star clusters drifting in the jellyfish's tail? Do they survive, or do they fade into the glow of the cluster? Let's talk about it.